So problem number 4 from third exam had two clicker questions, one about two disks and one about the center of mass of a system of balls. Both were used in lecture, and the answers are available in the lecture notes, but I'll give you a review of what the answers are for both of them. So let's start with the two disks. They're on a frictionless surface, horizontal surface. One has a mass m, the other has a mass 2m. You apply a constant force, the same constant force, to each disk for a certain time. Notice that both these things are underlined because they're critical, and you're asked for which disk gains the greater momentum over this time. So for 4.1, remember the instructions are to write and circle the correct answer. I'll just go ahead and do that to get started, and then I'll explain why it's the correct answer. The correct answer is C. They both gain the same amount of momentum. Okay, and the easiest way to explain this is to say, well, force is equal to delta P over delta T. Okay, you could think of this, if you want, as delta MV over delta T, or M delta V over delta T, or MA, where A is equal to delta V over delta T. And notice I'm using deltas, not derivatives, because we're asking something about the beginning and end of the motion, and the acceleration is constant because the force is constant. But really, I want to focus on this first way to understand the connection between momentum, time, and F. You might also remember that we defined the impulse. I, or impulse for us, is the change in momentum is equal to F delta T. So really all you have to say to answer this question is say, oh, change momentum is F delta T if the force is the same for both, and the time that the force is applied is the same for both. Then obviously the product of these two things is the same. Done. That's all you had to say. Now, many students in the class tried to do this problem the hard way. The hard way is to say, well, you've got a force that's applied, but the masses are different, so the accelerations are different. But the acceleration isn't momentum. Momentum is mass times velocity, so you then had to argue that, well, the velocities of the velocity of the lighter mass would be twice the velocity of the heavier mass because the acceleration is the same, but the heavier mass is twice the mass. And then you could say, but the mass of the lighter one is half, its velocity is twice, so those products are the same. And you can do that all correctly. And that's certainly the hard way to answer this question, when all you had to do was write down delta P equals F delta T, same, done. Okay, so that's the preferred way to answer this question. And the next question says, or part 2 of this question asks you for the center of mass of this system. Okay, and for that, let's start by writing down and circling the right answer, then I'll explain it. So the correct answer is B. Circle that. Okay. And the reasoning for this is, let's see, this is our XY system. You have masses at the positions, L0, 0, 0, and 0L. Okay. So they're sort of on the corners of a square of side L. The key thing here is to remember the definition of the position of the center of mass. Now, it's a two-dimensional problem, x and y axis, but let's just calculate the x component. The basic definition is you do the sums of the mass of each particle, and the position, or the x component of the position of each particle, divided by the sums of the masses. So just start doing that sum. Let's call this mass 1. Well, they all have the same mass, so I'll just write a little m for that. But its position, its x component is 0. The x component of this one is also 0. The x component of this one is L, divided by the sums of the masses, which is 3m. M's cancel, and so you're left with L over 3. And you'll have exactly the same formula if you do the y position of the center of mass. You'll have the y component is 0, y component is 0, y component is L. So you have an m times L divided by 3m, L over 3. Done. That's problem 4.